Today, we're going to go over deriving functions using the quotient rule. So let's say you had a function that looked like this. How would you go ahead and derive it? Now, in this case, you can use the power rule, but for this example, we're going to use the quotient rule. So, the quotient rule works for functions in this form where we have some function h at x is equal to some function f at x over some function g at x. So the derivative of h at x is going to be equal to the derivative of the numerator times the function of the denominator minus the derivative of the denominator times the function in the numerator, all over the function in the denominator squared. Like this form. Note, don't forget this negative symbol. It's easy to confuse with the product rule, which is f prime g plus g prime f, but the quotient rule has a negative symbol. And also, if you're simplifying, it's easy to forget the negative if you have multiple negatives that you have to cancel out. So make sure that you always have the negative there so you don't make silly mistakes. Okay, so let's go ahead and use the quotient rule for this example. Quotient rule. So when deriving this, we'll get h prime at x. We'll have the derivative of the numerator is going to be 0 times 3x minus the derivative of the denominator is just going to be 3. And then we multiply by 5. And then the denominator is going to be 3x squared, just like that. Note, it's all 3x and then squared. And then what we notice is this term easily cancels out. And then we're left with negative 3 times 15 is equal to negative 15 over, and then we have 3 squared is 9, and x squared is x squared. And then we notice we have a common factor of 3. And then we could cross that out right there. Oh, wait, no, that should be 5. Right there. Not a 3. Common factor 3. And then we get negative 5 over 3x squared. And that's our answer. Now, let's go ahead and use the power rule just to show that it works. The power rule, first we'll have to rewrite this function as 5 over 3 times x to the negative 1. That way the exponent is nice and clear. So, the derivative will just be 5 over 3 times negative 1 is going to be negative 5 over 3 times x negative 1 minus 1 is going to be negative 2. So x to the negative 2, which is equal to negative 5 over x over 3x squared. Note, you get the same answer regardless of what rule you use. If you have a simple function like this where you can use the power rule, I would go ahead and do it because the power rule is simpler. But if you have a more complicated function where you can't use it, you're just going to have to use the quotient rule. So, let's say you have another function. Let's say it's going to be 5 minus x over 10x cubed. How would you derive this? So, when deriving this, we see the derivative of the top is just going to be negative 1 times 10x cubed, and then minus the derivative of the bottom is going to be 10 times 3 is 30, x, 3 minus 1 is 2, multiplied by the top, just like that. And then we get 10x cubed squared. Next, we see we're going to expand this out. We're going to get negative 10x cubed minus 30x squared times 5 minus x over, so 10 squared is going to be 100, and then x cubed squared is going to be x to the 3 times 2, which is 6, according to exponent laws. So, if you were just asked to derive and you don't have to simplify, you can have either one of these answers. But let's say you're asked to simplify too. So, what we could see is in the numerator, we have a common term of negative 10x squared in both terms. So we factor out that negative 10x squared, we get x plus 3, remember we're factoring out a negative, times 5 minus x, over 100x to the 6. Now notice we have some common terms. So we can get rid of this 10 to make it a 1. We can get rid of this 100. This simplifies down to be 10. This x squared simplifies to be another 1. And this x to the 6 simplifies to be x to the 4. And then we end up getting this. So we get negative, and I'm going to distribute the bracket. I'm going to make it so be x plus 3 times 5 is 15 minus 3x over, and then we'll have 10x to the 4. Then we'll collect common terms. We'll get negative and then negative 2x plus 15 all over 10x to the 4. And then we'll just distribute the negative. We'll get 2x minus 15 over 10x to the 4. And that's your final answer. It's quite remarkable how we have such a complicated derivative like this, and we can simplify it down to something so simple like this. We're going to get into some more complicated examples when we get into the chain rule. So, thank you so much for watching, and have a good day.